In the previous video, we had started with we had introduced the concept of Charles' law. So just to get one of the equations out, so Charles' law is basically the relation between volume and temperature at a constant pressure and a constant amount of gas. So the basic equation in the end of the video that we learned was Vt, that is the volume at a particular temperature T, equals to V0, that's volume at 0 degrees Celsius, into 273.15 plus T by 273.15, where T is the temperature, a particular temperature. So when this is plotted on a graph between volume and temperature, they found that there was a straight line. Okay, you can see this is a straight line, right? So what happened was, here if you notice, this point is not V equals to 0. It's actually not V equals to 0. So what instead they did was, they tried to extrapolate the graph, the line, to get a point where volume equals to 0. So when we do that, it was noticed, so it was extrapolated. So actually it's supposed to be from there to here, but anyways, it was found that this particular number, that is minus 273.15 degrees Celsius, was the point at which this line met the graph. Okay, now what was unique was about the fact that irrespective of what gas, irrespective of the kind of gas, all the gases seem to be meeting the x-axis at minus 273.15 degrees Celsius. And that is why this number is very important. So what happened was, so the zero first of all, let's get this straight. 0 and the negative value of volume is not possible, right? Because you can't have volume as a negative. So Charles instead proposed that this minus 273 degrees is the lowest possible temperature. So this value did not depend, like I told you, even if they did for various gases at various temperatures, they noticed that no matter what the gas was, it met this number. Oh, sorry. So it met the x-axis at minus 273 degrees Celsius. And so that's when it got scientists thinking. So at 273, now let's look at the volume. So at T equals to minus 273.15 degrees Celsius, volume equals to V0. We're just going to substitute. So 273.15 minus 273.15 divided by, oh, you guessed it, 273.15. And so V equals to 0. And no matter what the gas was, this was the case. So minus 273 is the lowest possible temperature. And below this temperature, so below minus 273.15 degrees Celsius, volume becomes negative. And volume cannot be negative. You can't have a negative volume, right? So that temperature is called as absolute zero temperature. So this lowest possible temperature is called as absolute zero temperature. Okay, so Lord Kelvin was the one who suggested this. He said that, okay, let's give a new scale, that is, you guessed it, Kelvin. If you remember, we had learned about the SI unit for temperature. We didn't say degrees Celsius or Fahrenheit. It's actually Kelvin. We learned about the various scales and how they are related to each other. Now you know why. So he said, he called this the Kelvin scale, and it's also called the thermodynamic scale of temperature. So according to this, 0 degrees Celsius equal to 273.15 Kelvin. So if you have it in Celsius, you just have to add 273.15 to get the value in Kelvin. And that is what is the Kelvin scale. So let me just once again recap. First of all, when we got this equation, they plotted the graph and this was what they found. They noticed that if the volume was not zero, okay, it didn't meet the point, the zero over here. So what they did was, instead they extrapolated it. When they extrapolated the graph, the line, it met at a particular point, that is minus 273.15 degrees Celsius. And this value is very important because irrespective of the nature of the gas, irrespective of the temperature, no matter what the temperature or the nature of the gas was, they noticed all of them seem to meet at this minus 273.15. So there has to be something unique about it, right? So first of all, volume cannot be zero or it cannot be negative. So at minus 273.15, volume is considered zero. And below that, volume is negative, which is not possible. So they decided that minus 273.15 degrees Celsius is the absolute zero temperature. And that's when Lord Kelvin came in and he called it the Kelvin scale. Okay, and he said that 0 degrees Celsius equals to 273.15 Kelvin. If you remember, we had learnt about the Kelvin scale in the first chapter. The SI unit of temperature is actually Kelvin, despite the fact that we actually use degrees Celsius for our day-to-day applications. Like temperature, what is the temperature today? We use degrees Celsius. So, so he called it. So adding 273.15 converts the degrees Celsius to Kelvin. So it converts it to the Kelvin scale. Now we know Charles' law is Vt equals to V0, 273.15 plus T by 273.15. Now let's assume that T0, the temperature at 0 degrees Celsius, so it's T0 equals to, temperature, the absolute zero temperature, so 273.15 Kelvin. Okay, and T will be 273.15 plus the temperature, whichever value. So if it is 200 Kelvin, if it's 300 Kelvin, then it will be 273.15 plus the difference, right? So we are assuming that these are the two temperature values. Then this will get changed to Vt will be equal to V0, okay, into Tt by T0. Okay, so this again can be simplified as Vt by V0 equals to Tt by T0. So basically V2 by V1 equals to T2 by T1. That is the temperature and volume at various conditions. So from this we can say that V1 by T1 equals to V2 by T2, which will be a constant. So V by T is actually a constant. And remember, for Boyle's law, we call the constant K1. In this case, it is going to be K2. So volume equals to constant into K2 into T. That is the constant, right? So K2 into T. So K2 is actually going to be determined based on the pressure and the amount of gas. And it's going to be expressed in terms of the units in which the volume is expressed. So the Charles law states that pressure remaining constant, the volume of a fixed mass of gas is directly proportional to its absolute temperature. So pressure and the amount of gas is constant, fixed mass of gas. So the amount of gas is constant. The volume is directly proportional to the absolute temperature. You can't just say temperature, you will have to say absolute temperature. Okay, so with that, we're done with Charles' law as such. The next video we will be talking about the graphical representation. Oh, 1 minute. At T0, that is the absolute temperature, the value is going to be 273.15 Kelvin, and then we are basically taking to TT at a particular temperature T as 273.15 plus T. So we are basically substituting these two values in this equation. That's where we got the relation Vt by V0 equals to Tt by T0. Now this can be written as V2 by V1 equals to T2 by T1, or V1 by T1 equals to V2 by T2, and V by T is a constant K2. So V equals to K2T. With that, Charles' law is basically when the pressure remaining constant, the volume of a fixed mass or fixed amount of gas is directly proportional to the absolute temperature. In the next video, we will be discussing the graphical representation of Charles' law. Do check it out.